Hello all my geometry people, this is Mr. Longo here, and we are going to cover surface area and volume for composite figures. And there are two different types of composite figures we are going to work with, and one of them is a stack and another one is a hole. Now, the trickiest part for each of these is finding the surface area. And we're going to try to explain this to you while we're working on a two-dimensional surface. But when we're talking about surface area, imagine we're painting part of a three-dimensional figure, okay? So if we were to look at this stack, which is a cone on top of a cylinder, we can see that we have a circle base, and we have a cylinder and a cone, and all of it, because they're stacked so nicely, have a radius of 3. But now what you need to pay attention to is what's actually exposed. So if we were to look, we have a circular base, but only one of them is exposed. We do not have a top of a cylinder exposed because the base of the cone is covering it up. So the first thing we're going to do for the surface area is we're going to find the base area, and to do that with a circle, it's just radius squared pi. So the area of the circle is 9 pi, and of course that would be meters squared, and that's just the base area for the bottom of this figure. And we're done with the base part. But now we need to imagine that we pick up the paintbrush and we're going to paint just the lateral area of the cylinder. So since we just painted the one and only base, if we were to paint the lateral area of the cylinder, it would just be what's going around. It has nothing to do with the bases. So we know to find the lateral area of the cylinder, to do that, it is circumference of the base times the height. So the circumference of our base would be 6 pi times the height of 10, which is going to give us a lateral area of 60 pi meters squared. And again, that's just for the cylinder. And the last part of this figure, we have the lateral area of the cone. So if we were to find the lateral area of the cone, that would just be painting the top of it. Again, the base is not exposed. So to do the lateral area of the cone, remember, lateral area of a cone is half of your circumference, which we have already established is 6 pi, times the slanted height, which is 5. And that would give us 15 pi meters squared. So what we just did there was paint the entire exterior of this stack figure. And if we were to erase this just so we can see some other stuff later, after we painted all of it, you have to take your lateral area of the cone, your lateral area of the cylinder, and the base area of the one and only base exposed, and you just add them together. So 15 plus 60 plus 9 is going to give us 84 pi meters squared. Okay? So that's how we do surface area. Now to do volume, volume is actually much easier. To do volume, all you have to do is find the volume of each shape and add it together. So if you wanted to start with the top, the volume of the cone is 1/3 times the area of the base, which we know is 9 pi, times the inside height of the cone, and we just multiply that together, and we get 12 pi meters cubed. Then we have to do the cylinder. The volume of the cylinder is going to be equal to the base area, which we know is 9 pi, times the height of the cylinder, which is 10, and that's going to give us 90 pi meters cubed. So to find the total volume, all you have to do is add those two together, and you get 102 pi meters cubed. Okay? So that's how you do a stack. Again, the more challenging one is the surface area because you don't add in all the bases. You only add in which bases are exposed. Okay? Next, we're going to move on to a hole. So what we do is we take a three-dimensional figure and then we put a three-dimensional hole going through it. To do that, it is, again, fairly simple for volume, but a little bit more challenging when it comes to surface area. And we'll show you why. So let's take a look at what one of our bases actually looks like, and I'm just talking about one of the bases. So the base of the entire prism is a square, because we can see that it's 6 by 6. But we also have a hole in the base that's 2 by 2. So if we were finding just the base area, we would have to find the area of the big square, which is 6 times 6 is 36 units squared. And then we also have to find the area of the hole that's in the square, and 2 times 2 is 4. So the area of the base we would have to subtract. So we would have 32 units squared just for the base. Okay? Now from there we need to find the lateral area, and this is where things get a little bit tricky. If we were to shade the base so you can see it, we would color this side. And of course we would color the other side if we could. And that's just the base. If we wanted to do the lateral area of the outside of the figure, we would have to paint all 4 of these sides. Okay? Now again, the lateral area of the outside figure would be found by doing the perimeter of the base, which is 6 times 4 is 24, times the height of 10, that would be 240 units squared. That's the lateral area of the outside. But what I want you to imagine now is if this was sitting on your desk and you were about to paint the entire figure, you would actually have to paint the inside of the hole as well. And that's also front to back on all 4 sides. So what we're talking about here again is lateral area of the hole. So the lateral area of the inside is found the exact same way. It's the perimeter of the base, in this case it's 8 times 10 is 80 units squared. And since we had to paint the outside and we had to paint the inside, we're actually going to add those together. So to paint this entire figure, what we would be doing is taking our 240 for the lateral area of the outside, plus 80 for the lateral area of the hole on the inside, plus 2 bases. Remember, there are 2 bases, a front and a back. So we would have 2 times the base area of 32. Okay, and then we would have to add all of that together. So we would have 320 plus 64, and that would give us a grand total of 384 units squared for the surface area. Now again, as mentioned, volume is going to be a lot simpler. When we work with volume, all you have to do is find the volume of the big figure and then subtract the volume of the hole that you cut out of it. So to find the volume of the big part, all we have to do is take the area of the base, which we have already found is 36, and multiply that by 10, and that's going to give us 360 for the outside, or shall we say the full volume of this figure without the hole. And then we have to find the volume of the hole. And to do that, we just take the base area of the hole, which is 4, multiply that by the height of 10, and we get 40 units cubed. Now we just have to subtract those, and the volume of the whole shape is 320 units cubed. So again, when you're working with composite figures, volume is easier. If it's a stack, you just find the volume each, add it together. When you have a whole, you just find the volume of each and subtract them. When it comes to surface area, you need to make sure you're paying very careful attention to what you would be painting if this was sitting right on your desk. All right, that's it for this video on composite figures. This is Longo, and I'm out. See you, bye.